So in this video, we will be going through um, the proof of cosine rule itself. So let's just draw out the cosine, the triangle. Okay, this time let's name the base as C. Let's call this perhaps A and this as B. Okay, now let's draw the height of the triangle from here to here, and we'll call this H itself. Okay, and let's perhaps label the length from here to here as x and as c minus x. Okay, so we'll be using the theorems for the right angle triangle itself to help us prove the cosine rule. Okay, so basically we will use your Pythagoras theorem as well as Torah's law to help us prove your um, cosine rule itself. Okay, so let's start. Okay, you realize that there are two right angle triangles. We have this right angle triangle over here, and we have this blue right angle triangle over here. Okay, but they share a common height itself. Okay, so what we can do is we can equate that. Okay, we can say that, okay, by Pythagoras theorem, okay, we will have okay, from the red triangle itself, h square equals to b square minus x square. Okay, the reason why is minus because b is your hypotenuse. Let's call this equation 1. Okay, and then from the blue triangle, we can also use the same h square. So h square equals to a square minus c minus x, the whole thing square. And let's call this equation 2. Okay, so by simultaneous equation, because both the left hand side is h square, I can substitute equation 1 into equation 2, and I will end up with this following equation: b square minus x square equals to a square minus c minus x, the whole thing square. And if I expand this c minus x square, I will have b square minus x square equals to a square minus bracket c square minus 2cx plus x square. Okay, and of course, once I open up the bracket, I will have b square minus x square equals to a square minus c square plus 2cx minus x square. And if I bring everything to the right, to the left hand side, and I just leave a square alone, okay, I will have b square minus x square plus c square minus 2cx plus x square equals to a square. Okay, and switch them position as well as simplify. You have a square equals 2. So let's rearrange the terms. So I have b square plus c square minus 2cx, and the plus x square and minus x square will cancel each other out. So now you realize that if we go back to our original cosine rule itself that we are trying to prove, which is a square equals to b square plus c square minus 2bc cos a, cosine a, you realize that I am almost there. The only thing is, how can I make x to be b cosine a? And that's where your trigonometry comes into play. So if we look back at the triangle, red triangle again, you realize that the angle opposite the length will be labeled as angle A. So based on this thing itself, okay, if I just take a look at this length, which is the adjacent, and this length, which is the hypotenuse, okay, I can form another equation, okay, using ka. So cosine A is equals to the adjacent over hypotenuse. Okay, making x the subject, I have x equals to b cosine A. And if I sub this equation, let's call this equation 3 into equation 4. So sub 3 into 4. Okay, I will end up with a square equals to b square plus c square minus 2cx. X is b cosine A. So if I rearrange everything, I'll have 2bc cosine A itself. Oops, I've got a c there, cosine A. Let me write this nicely. Okay, 2bc cosine A. And that is what I want to prove. Okay, so slightly more complicated than the proof for sine rule, but nothing new actually. You are just basically using Pythagoras theorem, okay, as well as your Tua Kaso. Okay, of course, if you read online, there might be other proofs. Okay, often in maths, okay, there's not just one proof, but there are more than one way to prove your theorems and identities itself. Okay, so that's it for the proof. In the next video, we will take a look at when can we apply the cosine rule to find unknown lengths and unknown angles. How is it different from sine rule itself? All right, so stay tuned for the next video.